Hi students, now I am going to teach a topic of dynamometer as ammeter, voltmeter. So let's start the topic dynamometer as ammeter, voltmeter. First, case 1, dynamometer as ammeter, dynamometer as ammeter. So then next, to connect or to convert dynamometer as ammeter, connect current coil and pressure coil in series, and this series combination is connected in series with load, and a series combination connected in series with the load, and this is pressure coil. So this is a load. I1 means current through current coil, Cc by 2, Cc by 2, and this is my total current or load current coming out, and once it will become I2, current through pressure coil, DC, phase neutral. So guys, since all are connected in series combination, I1 is equal to I2 is equal to I. Since phi is equal to 0, means all are connected in series. All are connected in series. So phase difference between I1 and I2 is 0. And the next, TD is equal to I1 I2 cos phi dm by d theta. This we have already derived at final steady state position. So finally TD becomes I1 I2 dm by d theta. So at final steady state position, at final steady state position, final steady state position, Tc equal to Td. So Tc equal to Td means Kc theta is equal to I square dm by d theta. So theta equal to I square by Kc dm by d theta. Then next, so let's have how pointer will deflect. Then next, so what is, you will have current coil now. This is your current coil is divided into two halves. Now current coil is divided into two halves. This is I1 means current through current coil. This Cc by 2. Cc by 2. Now pressure coil. We have pressure coil. It's I2 coming out and going out. So my pointer is moving to what coil? So far it's connected to what? Connected to pressure coil. It is connected to pressure coil. So this is minus 45, 0 degrees. This is plus 45. So what is the purpose of it is so this is our arc pointer theta or 0. So this gives minus 45 degrees. This gives 45 plus 45 degrees. This is pointer. So minus 45 to 45, it can rotate as 0 to 90 degrees. Pointer has a feasible to rotate at 90 degrees. So what is the meaning of it is I want some linear portion now. I want some linear portion. So this is our signal. So what this is of 90 now? This is of 90. This is 45. This is 45. And this is minus 45. This is plus 45. So what is m of theta? So this portion is straight line, is very linear. This portion is very linear. So m of theta is equal to m max sine theta. So dm by theta is equal to constant. Why it has a linear? Dm by dθ, why it is of a constant? See, try to understand here because it is of a constant. So then next, what are the points? How to get all this? First locate zero mutual inductance position. First locate a zero mutual inductance position. Then with the reference to zero mutual inductance, the reference to zero mutual inductance position, allow the pressure coil from minus 45 to plus 45 degrees. Then next, dm by dθ is exactly dm by dθ is exactly constant from minus 45 degrees to plus 45 degrees only. The span of the scale is 90 degrees. Span of the scale is 90 degrees. The next division of the scale. Division of scale. So division of the scale will be like this. So what is division of the scale? So this is 90 degrees minus 90. This is, sorry. So I can give here as a minus 90. Here it has a plus 90. So we can give here as minus 45 plus 45. So this is m of theta. So for minus theta, so for plus theta, so m of theta is equal to m max. This is a sine signal, m max sine theta. Then next, dm by d theta is equal to 1. Then next, as the curve is linear from minus 45 to plus 45 degrees. The pointer indicates between 0 degrees to 90 degrees. Then next, dynamometer, ammeter has pure square law scale, has pure square law scale, works for both AC and DC, scale calibrated, scale calibrated to read RMS value, scale calibrated to read RMS value. The next, note all square law instruments, square law scale instruments works for both AC and DC, whereas linear scale instruments works for DC. Then next, let's go for case 2, dynamometer as voltmeter. Dynamometer as voltmeter. To convert dynamometer as voltmeter, connect current coil and pressure coil in series. This series combination is in parallel with the load, is connected in parallel with the load. So we can have like this. This is load, phase, neutral. So all are connected in this current coil. This is pressure coil. Pointer is connected. And this is RSC. RSC means the resistance of my pressure coil. A total current. This is anyway I1, I2, a V. Voltage across the load. Okay, now. So anyway, I1 and I2 are connected in series. Since phi equal to 0 degrees, I1 is equal to I2 is equal to V by RSC. So then next TD is equal to I1, I2 cos phi dm by d theta. So anyway, phi equal to 0 and I1 is equal to I2 is equal to V by RSC from the diagram. So TD is equal to V by RSC whole square dm by d theta. Then next at steady state position TC equal to TD. Kc theta is equal to V square by RSC square dm by d theta. So theta is equal to V square by RSC square 1 by Kc dm by d theta. dm by d theta. So from this we can directly write theta directly proportional to V square RMS. So this is a non-linear scale. This is a non-linear scale. The next dynamometer, voltmeter. Dynamometer, voltmeter has pure square law scale. Works for both AC and DC. Calibrated for RMS value. Calibrated for RMS value. Thanking you.